Hey everyone, this week StatCast recently came out with spin direction data and spin axis data, active spin, comparing observed versus inferred data. Really cool stuff. So I'm going to show you today how to scrape that leaderboard that you'll see on there and be able to make some basic inferences with that data. So obviously for us to load in that data, we will need our regular library, which is tidyverse. That's a mainstay for this channel. No baseball R today, unfortunately, but I'm sure in the future we will need that to get spin direction leaderboard. So the three that we'll need today are Tidyverse, XML2, and RVest. And if you don't have any of them, simply just run this command, install.packages, and then in quotes, whatever package you need, whether it be Tidyverse, XML2, or RVest. If you have none of them, you would run that line 3 times. Obviously, remove this comment here at the beginning so you can run that code and R is able to process that. But to move on, so we're going to run these 3 lines of code, and then what I'm going to show you is essentially creating another function that I've done in my last video with those scraping Savant tables, where we're going to scrape that leaderboard that we see on there and see what kind of data does that leaderboard give us when we scrape it, and how can we apply it in, say, a few plots. So first we'll obviously load in these libraries, so tidyverse, XML2, RVest. Hitting all of these libraries because XML2 and RVest allows us to scrape that data, though we don't necessarily need it. It's just a good backup to have should you run into any issues in terms of scraping data. So what I'm going to do now is basically create that function. So I'll just call it spin direction leaderboard. Create that function where I say num pitches, so that's the number of pitches, pitch type, and that will automatically set to equal all, and I will explain that here in a second. And then throwing hand equals all, but this time with lowercase l's, and then team is the last part of the function. And so why we're doing that is when I was looking at this URL, in terms of selecting pitch types, when you wanted to select all of the pitch types, they literally had in that code all in all caps to get all of the pitch types. Throwing hand, this is essentially what we're going to do is like an if-else statement where we're saying if throwing hand does not equal all, then filter by those necessary filters. So, and then number of pitches. So if you look on the leaderboard, I'll leave a link in the description of the leaderboard below just so you can see it visually prior to. But then you can kind of see it when I run through this with you here shortly. But it gives you a distinct number of pitches. I believe it's 1, 25, 50, 100, 200, 250, so on and so forth. I don't remember the exact number off the top of my head. But it allows us to get those spin direction data from those pitchers that had the minimum threshold of pitches. Now, if you want it for everybody, you can absolutely do that too, with that one pitch. And then pitch type, there's different amounts of pitch types, and they're using the short form version of the pitch types, not like the long form where it spells out four-seam fastball or sinker, etc. Then throwing hand, obviously left to right, aside from all, and then team, the team codes. So what I'm going to do here is actually bring in some code that will help you explain like the acceptable functionality should you want to run that in the future. So here's the acceptable team names for that team argument. More or less like just 3 letters except for the Padres, which are SD, the Giants SF, the Rays, which are just TB, And so I have it just organized by alphabetical by division. So like the top row is all AL and NL East, middle row AL, NL Central, bottom row AL and NL West. And the throwing hand arguments are left or right, and the pitch type arguments are four-seam fastball, which is FF, aside from all, I should say, and then sinker, changeup, cutter, or excuse me, see, sometimes that'll mess me up too, but CU is curveball, and then FC is cutter, and then slider. So you get those spin direction data. So now what I'm going to do next is basically add in some more code, and then I'll go by it line by line, and then fill out the rest of that spin direction leaderboard. So first, we have basically a bunch of if statements, and you don't have to really delve into this too much of trying to understand it. It's just saying, if there's no team argument, I'm trying to make the team argument optional because obviously if you want to see all teams, if that becomes a required argument, then you would have to filter by something. So I said if missing team, and then add another if statement by saying if throwing hand does not equal all, paste this URL into our code. So baseball savant, MLB.com, leaderboard, spin direction pitches, years 2020, since that's the only year we have spin direction data, and then the and min, so that's basically saying what's the minimum amount of pitches, and then that argument num pitches comes in here, and then another comma to say, hey, we're going back to our URL, and sort equals 9, and sort, that's just basically just sorting direction. I mean, you can change that if you want. I just left it as is. And then and pitch type equals, and then that's where the pitch type argument comes in, and throws equals, that's where throwing hand comes in, and then and player name, and team, and CSV equals true. So we get that CSV file relatively quickly. And then on the opposite side, if we say throwing hand equals all, it's pretty much the same thing, except now we're saying and throws equals and player name equals so on and so forth. So that allows us to get the missing team argument function of it. Now, just to make sure that we have this correct. So far we have one. So just make sure these squiggly brackets are aligned with each other so we can move on to the next point. And don't go to the end, go to the second in the end here, and then we'll add another else statement. So I'll just add a space just to make it a little bit more clear. I'll say else, and again, basically saying the same thing. If throwing hand equals all, paste this URL. If I can figure out how to copy and paste, wow, sheesh. So now, instead of saying something like this, now we're going to convert this to say and team equals, add the parentheses, or not the parentheses, quotes, and then say team, comma, add that parentheses, and then same down here where you say team, comma, add that other quote. I keep saying parentheses as quote, so I apologize in advance if it seems like I'm saying parentheses when I'm actually referring to quotes. That sometimes happens. Hey, all is well that ends well. So now to get the end function of it, because obviously we want this leaderboard to return something, so we're going to need to figure out how to return that. So first, what we're going to do is you can actually, with that CSV URL, since we're saying and CSV equals true, it's automatically generated as a CSV file. So we don't necessarily need to go through the XML2/RVEST way, but you may or may not have to. Let me know in the comments if you are having trouble with it, and I will show you like the alternative code to this. But basically what we're going to do is from the readr package, which is under tidy, we're going to use read CSV URL. And so we're going to call it under payload, which is a Bill Petty classic. The creator of Baseball R, though people do believe I created Baseball R, I did not. That was the miraculous work of Bill Petty. All I am is a contributor on that. So anyways, so payload, we're going to read in that CSV that we select and then return that payload. So now that we have this full function in here, it appears in our environment. So that means, hey, we have that spin direction leaderboard data. So now we're going to do something really simple. And we'll say spin axis data. We're going to say spin direction leaderboard. And now, since we have pitch type equals all already as an argument, throwing and equals all already as an argument, and team, now that we have in that functionality to make it optional, we can just focus on number of pitches. So I will just say spin direction leaderboard 1 to indicate, hey, we're just going to get every pitcher who threw at least one pitch in 2020 and their spin direction data. So now let's go ahead and view it. And so we obviously have NAs for year. You can obviously add like a mutate function by saying mutate year equals 2020. So that's the only year. But now we have it sorted by last name. So Bruce Zimmerman is the first that appears. And here's the columns that you get. So you'll have player ID, which is good because we're going to merge it with our StatCast data that we have. And then pitch hand, the API pitch type. And again, that's the pitch types that we're putting in. Number of pitches at this pitch type. Average release speed, average spin rate, average movement in inches. I don't know if that's the absolute value or not, because obviously for some pitchers there is a negative movement in terms of, let's say, righties with sinkers. And then the Allen active spin percentage, so that's from Alan Nathan, and I will leave a link, the description below of some of his work with spin efficiency and spin ratio, active spin, so on and so forth, that you might find very useful in researching this, because this is a fairly new concept to a lot of people, and the more researchers we have, the more people that we have trying to delve into this and understand, be able to explain it in some way, shape, or form is great for the baseball community. Active spin is another thing where that's basically StatCast version of computing that active spin / spin efficiency. That's another way to say that. And then this is where you'll get the Hawkeye measured and the movement inferred. So the Hawkeye measured is on that, back on that leaderboard page, is the spin-based movement. So in this case, it's the spin direction. And then the movement inferred is the spin direction, and that's measured in degrees. So the movement inferred is the observed. So this is the observed column in the StatCast file, and then this is the spin-based column in that StatCast page. And then the API pitch name, then the active spins formatted, so there's no decimal points, and then Hawkeye measured clock minutes, movement inferred measured clock minutes. Again, it's just more or less measured. Don't really know much to explain with that, so if anyone wants to explain those two columns, great, leave it in the comments. Love to hear it. And then just the differences in the measured versus inferred, and then the diff2 is just the absolute value of the difference, multiplying by -1 if it's negative. That's essentially what it means. Then now we're having the difference measured in inferred minutes as well between the two. Then this is where we'll get like Hawkeye measured. So this is spin-based measured clock hours, spin-based measured clock minutes. And this is observed inferred clock hours, observed inferred clock minutes. And then the difference between the clock and the hours, and then the difference between the clock and the minutes. And then again, spin-based, which is listed as Hawkeye measured clock label. And then the observed, which is movement inferred clock label, and then that difference. So essentially, what we're trying to figure out is differences in how spin direction can manipulate, say, maybe in spin rate or spin efficiency. What is good spin efficiency? Is it better to have higher spin efficiency? Is it better to have lower spin efficiency? Being able to ask these questions now with this data, but now you're able to pull all of that data, and if you would like to, add it to your database or something like that, you can obviously do that. You can use DB from the DBI package. For those who already have a StatCast database, you can say DB Connect, RSQ Lite again, SQLite in parentheses, and then get that, StatCast database that you created before, and then you can say dbget or dbWrite table, and our connection is db, and then we can say like spin direction data, and then our value is obviously that spin axis data. So spin axis and spin direction are used in the same manner. They're both to explain the same thing. In terms of how a spin axis works. So it's just basically measuring off a clock. If you haven't already looked at the page, like this is going to be hard to explain. So look at that page, and they have a little quick glance at the top that'll help you kind of understand what it means. And I've also written an article, which I'll leave you a link in the description below as well, about what we can measure from that StatCast movement. I've written that about roughly a month ago or so. But being able to see that as well can help you kind of explain, or at least understand, what spin direction means and what it does. So you can write that table and then obviously disconnect your database. So I'm just going to remove these. And then another quick way to do it is basically saying write underscore CSV from the readr package, and then obviously spin axis data, and then say, spin axis data or spin direction data, whatever you want to call it, .csv, into your files. So at least now you don't have to run that leaderboard, and then just use that in the future if that's the way you prefer. I feel like running this function, it took hardly any time at all to figure that out. So what I'm going to do next now is load in our StatCast data set that we have, and if you don't have it, don't worry about it. I will leave a link in the description below of a Google Drive link that will allow you to download the entire 2020 StatCast season of data, just so we can create kind of this idea of what spin direction can bring to us. Again, this CSV file will be in a link in the description below. So if you don't have it, go get that file and then put it in your working directory, and we'll be able to read it. So we will read our CSV, StatCast data underscore 20 CSV, loads that in, and now we're going to add kind of some more columns and figure out, okay, maybe there's something with like zone location. So from that StatCast data set, we'll say StatCast 2020, not 2022. We'll say zone location, and then we'll use a case when. And so case when is in the dplyr package, and it's basically a SQL type of code, and essentially it's an advanced version of an if statement. So what we're going to do here is I'll just break it down line by line and help you understand. So this is, we're saying right here is we're saying if it's in zone 1, or if zone equals 1, 2, or 3, we add the tilde sign to indicate we want that to be a high zone. So that zone location, because we're getting those zone locations based upon the zone that StatCast gives us. So we're going just further on down the line, zone equals 4, or zone equals 5, or zone equals 6. Let's call it median, and continue going on down the line. We'll say 7, or 8, or 9. We'll call it low. And then we'll add another thing. It's not perfect, but I think just for this intent and purpose, we will use it as such. So we'll just say if plate Z is greater than or equal to 3.5, which is considered the top of the strike zone for the StatCast data set, considered a high pitch as well. Now again, not perfect because each batter varies, but we'll at least have that in our data set, and then as well, we'll say zone equals 13 or zone equals 14. Call that a low pitch. And same with plate Z, so we'll say plate Z is less than or equal to 1.6. We'll also call it a low pitch. Then the last thing about the case when is after you run it, you need a true command that basically says if it doesn't fit any of those arguments, what else do you want it to leave as? Now we'll just leave it as NA character. So we'll run this code. Should work. It does. Although it's not going to be perfect because the actual numbers may vary, we're going to take those average spin direction numbers and apply it to our full StatCast data set. So I'm going to say StatCast 2020 left join from the dplyr package. And we will say that same data set, StatCast 2020, the spin axis data that we created, and we'll say by equals combine pitchers, since that's the column of IDs in our StatCast data set, equals player underscore ID. Then we'll add another one where it says pitch name equals API pitch name. So that way we have those correct pitchers and pitch types defined with that spin direction data. Now you could also use pitch type. That's not a big deal. I just prefer pitch name because, again, liking to spell out the pitch name. So we're going to run that. Perfect, we got it in there. So now let's view a plot or two of kind of a basic distribution based on the data that we have, and kind of see, what can we explain with spin efficiency, what can we explain with maybe spin direction, so on and so forth. So we're going to say StatCast 2020, piping operator, dplyr, filter. We'll start with sinkers, since that seems to be the popular topic on Twitter. And we'll say pitch type equals sinkers, and then zone location equals low. Add that piping operator, and we'll say dplyr group by, we'll say that Hawkeye measured clock label. So that spin-based direction that's on that StatCast that is known as Hawkeye measured clock label. Then we'll say he throws, and the reason why that, so we can differentiate between pitchers throwing. Then we'll say dplyr summarize. We'll say number of pitches equals n. And we'll say active, or no, we won't do active spin yet. We'll say spin rate equals mean release spin rate. And we'll say NA remove true. Add that piping operator. Now we're going to go into our ggplot. So ggplot. Now once we're in the ggplot, instead of using piping operators, we'll use plus signs. So ggplot, and we'll say geom bar. And then our AES, which is our aesthetics, to understand, hey, we're going to add these together when we add future data points. We'll say Hawkeye measured clock label, end pitches, and we'll say fill equals active, or not active spin, sorry, I'm used to the last plot, spin rate, and then add two more things. Position equals dodge. So essentially that just means we don't want bars like stacked side by side. We want a little space between the two. And then stat equals identity, and quotes as well, because we want just the basic stat of what we've already grouped together. And I like to add theme classic. You don't have to if you don't want to. And we'll say just a basic GG title. Say spin direction distribution on O sinkers. And this is where the pitcher throws comes in. So we'll do a facet wrap, and what facet wrap does, it basically generates the same plot, but for each pitcher throw. So for each left-handed or right-handed pitcher, and we have to use that tilde sign to indicate, hey, we want to separate by those unique variables in that P throws column. So I'm going to run this. You can kind of see it over here in the plot, and so I'm going to pull this up shortly and show you that plot. We can see the spin direction distribution on low sinkers with left-handed and right-handed pitchers, and it looks like a lot of pitches were thrown right around the 11 o'clock area for sinkers. And then for lefties, it looks like around 1, 2 o'clock area for those clock labels. So at the very least, we can understand, hey, most sinkers are thrown at this this clock in terms of spin direction, and then we can see spin rates around 2200 RPMs, and it looks like as you get closer to 12 o'clock, not necessarily because there's too few of data for right-handed pitchers, but spin rate looks like it's increasing, maybe around that 1130 area, this bar right here. And then on the left-hander side, it looks like right around that 130 areas where it looks like spin rate is highest. Again, that's we're just describing this data right now. We're not making any future assessments of it. Just a basic idea of what to look for. Now let's look at active spin / spin efficiency. So we're going to just copy and paste the same code, but instead replace spin rate with active spin. We'll say mean active spin, remove NAs, and replace the fill with the active spin as well. And now we can say spin direction distribution on low sinkers. And we'll say our subtitle equals spin efficiencies by, oh, wow, I cannot spell spin efficiency, so I'll just say active spin. Active spin percentage by clock time, we'll say. And again, we'll do that facet wrap. So here we go, sinkers. We'll look at the active spin here in a second. We can see the similar distribution, but now instead of the fill being spin rate, now it's active spin. And we can see, how does the spin efficiency look as you move alongside a clock? So it appears that the spin efficiency tends to decrease as a right-handed pitcher moves closer to 12 o'clock. And I did forget to mention earlier that this is from the catcher's point of view. So typically other tracking types are viewing it from the pitcher's view. So a 1 o'clock fastball from a right-hander is actually 11 o'clock in this type of scenario. So it's from the pitcher's view, so it's in reverse in this case. So it looks like that as you move closer to 12 o'clock for right-handed pitchers, the spin efficiency goes down, and then it looks like as you move closer to 12 o'clock for left-handed pitchers, for the sinkers, the spin efficiency goes down. And it's interesting to see that kind of stuff. If you're familiar with any of Barton Smith's seam shifted wake work, this is a big thing of determining that with spin efficiency. So I'll leave a link in the description below of some of his work, and hopefully our group of researchers and myself. This is a big concept and a fairly new concept to a lot of us. So we're still delving in and trying to understand the data as best as we can. So wanted to get that out there for everyone, so that way, the more people that tend to research on it, the more type of data and being able to inference and describe this data and make future assessments for player development would be huge. So just want to get this out there, sooner rather than later, to help analysts with getting this data and then trying to understand it as best as they can. So thank you so much for watching. Really hope you enjoyed it. As always, if you like my work, go to my Patreon. I have a website now, robertfry40.webstarts.com. Feel free to go on it. My YouTube videos will be on there. All of my blog content, Finding the Edge podcast, so on and so forth, all on there. So please give it a look. I'll leave a link in the description below. We'll have a lot of links in the description below, but that's great because we're promoting content. We're promoting public baseball research. So thank you so much for watching and have a great day.